Let us assume to design a counter in a sequence 0, 1, 2, 3, then skip to A, then count to F, and clear the counter again. I will take the 74163. I will take a hex display for the output. And I take also a binary probe for the RC. You will see that even when I do runs here, the output, it is unknown. 2. Because the inputs, they are floating inputs. It will not counting until all the inputs are connected. So I will take a binary switch for the input. I will start here by P2. You know that when P and T are 0 means the counter holds. Here I need the clock signal. You know that when I want to do this one, this sequence, I have, when the counter reaches 3, we have to load A. And when it reaches 15, you want to make it clear or load a 0. You will see that at the beginning, when I try to do the feedback, I cannot get an output because the output is still unknown. So what I will do, I will connect the counter to a switches. At first, I need 2 switches here because I wanted them to skip to 10. It means that A and C will be 0, but B and D should be 1. So from the beginning, I will try to do this. Okay, this should be at 1. What about the load and the clear? I have to load a 3, but I don't have any output signal, so it will be unknown at the beginning. So I will try to take a switch here. Even here the load is 0. When I make a load 0, I get A because I load here. Now from this point it is working. For the clear also, I will connect a switch. You will see that when both of them are 0, 0, you know that the priority for the clear, but here in the simulation, in the logic work, that the priority for the load. So when I make a load is 1 and clear is 0, I make the clear. Now, I have to make a feedback 3 to load, and I will take inverter through RC to make the clear. See, I need inverter, not gate. This should be and it's supposed to be to that. Yeah. Now I will not. I just disconnect this signal. This. Okay. Now it is 0, Now I have to load the 3, so I need NAND gate with 4 inputs and 2 inverters. A NAND gate, this one. The 3, that means this is QA, QC, and QD. Now, even here, the P and T, it is, I will force it to be 1 here. You'll see that it is a normal counter here. So it will be counting when it is reached 15. It should be forced to 0. So it is reach 15, or it automatically also, even if I don't connect here the RC, because when it is reach 15, automatically it will make it clear, even if I don't connect anything to the clear. I want to make a load here at 3. See, I will disconnect here. See, I get the end. To overcome this problem, I will connect again here the load. Now I will make it a 0. Now I reset again. What I will do here to make I will make a clear. I will force the clear. To force the clear also, what I will do, I will connect this switch. Now I will make this one as 1. This is 2, 0. Now what I will do, I will make it as a clear here, and I will stop the counter from P and T, and even I will stop the simulation. Now I will try to do the feedback. For doing the feedback, I will make this one. For the clear, and this one should be for the load. And this one. Okay. Now what I will do, I will rerun the program. Here the P and T is 0. I will make it 1. So the counter should be now count as a normal counter. You will see that. Now when it reaches 3, I have to make a load here to A. Then it will counting up to F, and it should be clear again. When you're done from your design and you want to submit your work to your doctor, what you have to do, you have to make your program in the run mode. When you stop it, it will need initial, it will stop it, and you want to run the program again. It needs an initial value to make the feedback, but at the beginning, it doesn't have any initial value. So your output will be unknown. The doctor will think that maybe your design is incorrect. So you have to make the initial state for your design circuit. Then you have to save it when you finished from your work and make it in the run mode. Thank you.